I still think reviewing the slideshow, and if you got a topic on the slideshow that you don't understand, now you got to go to either your book or the prepware section of that topic. Is going to be the most efficient way to study. The deepest way to study would be to get your book out and just read chapter 10. We're in chapter 10. You can read chapter 10. Otherwise, while I'm lecturing, if you're taking notes, you could study your notes. Or you could study prepware for this section. The way to do prepware usually is not memorizing questions, which does help, but you take this questions in prepware, and when you get one wrong, you go, what area is this in? Oh, it's talking about pedostatic system. I realize I am not doing well in pedostatic, so let me go back to my book, chapter 10, and refresh myself on pedostatic. So, yeah, there's a lot of places we pull info from. I am not teaching you just to memorize facts and spit them back out. It's both facts, concepts, where to find it. So those are my recommendations. Flip to the slideshow, do some prepware, and read the chapter if you want to spend some more time. I have a note here I don't want to forget, so somebody remind me later, but Grandpa is leaking. He's got an incontinence problem. But the pedostatic system. So if you get done with your labs, that's one more thing to add to the extra learning. If somebody wanted to figure out where Grandpa's leaking from, it both helped SMAT, but also be a good experience. Now it's going to be a hassle, I'll tell you that already. And it's after today's lecture, you'll see kind of why. But Grandpa's leaking, and we can add that to the extra list. All right, here we go today, pedostatic systems. Chapter 10, and it does jump around quite a bit. We'll touch on a bunch of areas. In our aircraft, we have a pedo tube that sticks typically out the front. Sometimes it's under the wing, and there is air that's basically being forced. I hesitate to use the word into it, because what we're going to learn today is it's a sealed system. There is not air that's traveling through and exiting. It's air pressure pushing against it. So if I hold this out the window in the car when I'm driving very fast, it's pushing against air pressure. So it's actually sensing a pressure and sending that pressure down this tube to the rest of the aircraft. On cool airplanes like F-16s and such, it's right in the nose, the pokey thing up front, and they just look cooler, right? So I'm not a big 414 fan, maybe it's because I never flew in them, but they got one right in the nose. I'm like, okay. There's at least one cool thing about the 414. They got an F-16 pedo tube on the front. Most pedo tubes are going to have a drain hole somewhere on them. The idea is if I'm flying through the rain, especially, I might have raindrops that go right in my pedo tube, and there's air pressure that's trying to hold it in, and there's nowhere for it to go. We don't want that moisture and water to go all the way back into our system. So typically at the low point, there's going to be a drain hole, and they're tiny because, well, if it was a big hole, we'd lose all our pressure, right? So there'll be tiny holes. This particular one, it's actually right here. If it was mounted on the aircraft, it's kind of at the low point. On the beach jet, this thing's kind of mounted on an angle like this, and the holes are, I think there's one down here and two back here. Part of it is if moisture got in there, we don't want it to sit and freeze when the aircraft's not on. So they'll put one at the low point, but they'll also put some where ram air is going to push it out. So be aware of that on pedo tubes. I'll pass this one around. There's going to be drain holes on them somewhere, so when you're doing the test we talk about today, you're going to want to find the pedo tube drain holes and cover them up. So from our image, they're calling it a static hole on this one. That doesn't sound right. No.
Farther back.
This is just a funny picture. Some pedo tubes will have a static hole that has a second connection connected to it. This image just threw me off, and they have a static hole, but we're not really connected to it. There it is, drain hole. Thank you, Gavin. It's not a very good image. That should be connected up into here. That drawing, FAA.
So
this essentially is gonna be connected up into there to drain any moisture out of there. So ram air is coming in. There almost always is heaters in our pitot tube because we don't want moisture to get in there and freeze. So there'll almost always be electrical connections to our pitot tube. I just saw Dwayne here yesterday doing O's and P's with a guy, and I'm pretty sure he was asking, is the pitot tube heater working? Pretty common O's and P's to get. The easiest way to find out is just turn it on and wait a minute or two. Is it getting hot?
That's practical.
That's part of a practical. So,
I hope I get that.
yeah, so there's different ways to do it. You can check amp draws, you can do stuff, but is it working? Click it on and see where we're at. You may want to find the manual to see if it has specific ways. This one you notice has 2 heaters in it. Maybe only one heater is working out of the 2, but if he asks, hey, is the pitot tube working? You might want to clarify and say, am I just checking like a pilot checks? Yes, is it working? Or do you want me to confirm based on the manual? And he says, well, the manual. Oh, okay. Grab the manual and see what it says, right? So, pitot tube has heaters, has a drain hole, connected up to our airspeed indicator. The rest of our static system, a lot of times we use the word pitot-static system. Well, our pitot system is just that ram air. They put it in red here, the red pressure. Our static system is typically drawn from a port on the side of the aircraft somewhere. And the static system is just giving our instruments, hey, what pressure air are we in at the moment? And that's why it's typically the side of the aircraft. You did notice this pitot tube, maybe it has static holes on it. That's pretty uncommon. So side of the aircraft, usually there's one on each side so that if you're flying uncoordinated and slipping, they even each other out for one side or the other. So there's often more than one static port. This says alternate static source. Let's say you're flying in icing conditions and your static source gets iced over. Well, that would not be good because now my instruments can't read what they're supposed to read. So often inside the cockpit, there's a little valve or switch of some sort so that you can actually open our static line to the cockpit. Now the cockpit's going to be just ever so slightly different pressure than outside the aircraft. If I was teaching you guys as pilots, I would memorize if it's higher or lower. I used to know this. It's higher or lower, because if I switch my alternate static, my airspeed would actually change a little bit. You can do that research on your own. Point being, it's a little bit different pressure inside the aircraft than outside. So normally we leave that closed and we sense outside the aircraft. We are going to put that outside the aircraft pressure to our altimeter. That's pretty self-explanatory, right? Our altimeter has a aneroid, we called it. It's going to be a diaphragm or baffles with a vacuum in it, probably baffles. So all the altimeter needs to know is what's the pressure outside the aircraft, and I'll compare it to an absolute vacuum, and I'll tell you how high you are if you tell me the adjustment I need for today's pressure. Our vertical speed indicator, we talked about already how that is similar to an altimeter, but there's a bleed hole in it, a calibrated orifice. And as we go up or down, as the pressure changes, it'll tell you how fast it's changing. So it's connected to our static system. And then our airspeed indicator, well, that's a pressure sensing device in that it's going to compare ram air pressure into my pitot tube with the static pressure. So if you are not flying through the air forward, it's going to say, well, the pressure of my ram air is the exact same pressure as what's alongside my aircraft, right? That gives me a 0 for a pressure difference converted to airspeed. If I start flying really fast, I'm going to have higher ram air pressure than the air on the side of my aircraft. That's going to move my needle up to wherever is the appropriate calibrated spot for my airspeed. So that device is using both static and ram air. I hesitate to say it's the only instrument that does, because when you get into digital stuff, you got flight computers and stuff like that. But old school steam gauges, that's the only one that uses the pitot, is our airspeed indicator. Everybody tracking with me so far? Leo?
Yeah,
understanding is, as long as the tube is not faced forwards or backwards, it shouldn't. But, yeah, as long as you don't have a forward or backward slant, it should be the same pressure. Good question. All right. IFR flight, we talked a little bit about yesterday. The system, and there's 3 things that have to be certified within the previous 24 months, and that's always that fun question, right? So if it's certified on June 5th, you have until 24 months plus the end of June to have it certified again. So if it was certified June 5th, 2023, we're basically good until July 1st, 2025. And the 3 parts are our altimeter has to be checked by station. You can't do that. Our altitude reporting system has to be checked by a station, repair station. You can't do that. And the static system has to be checked to make sure it's not leaking. You can do that one. You have to do that one anytime you disconnect a hose or a tube. But that's the only one of the 3 an A&P can do. I see a hand back there, Yoder. All right, just waving. Hi, good to see you. So back to pressure being a measurement between those 2 forces. When we hook our fancy box up, what we're going to notice is, hey, are you connecting both of these or not? So for instance, if I want to check if there's a leak, picture there's a diaphragm between those 2, right? If I want to check if there's a leak between those 2 points or those 2 systems, I can run a vacuum on here and then plug it and see if the pressure stays where it's at. Now actually I said that backwards, excuse me, I take that back, I'm on the wrong side. I can add a little bit of pressure on this side. If I ran a vacuum over there, it'd be a problem. We don't ever want to have higher pressure on the static side than the ram air side. That's a thing. It'll actually wreck your airspeed indicator. You always want to have either the same pressure or higher pressure on the pitot side. So I would put pressure into the ram air and then cap it and say, hey, is the pressure staying? If it is, I don't have a leak. If the pressure goes away, oh, I have a leak. And we're going to cover that in detail later. There's multiple ways to do it. I made this today. I went over to Menards, made this guy. And it's not just to get you guys that fall asleep in class, right? Because I don't think it really work, but I might keep it around just to see what happens. But that's going to help us determine if we have a leak in our pitot system. In our static system, that's the side we can run a vacuum on there by covering up this hole and run a vacuum and then stop the vacuum and say, hey, is it holding? And what we can watch is we can just watch our altimeter. If I put a vacuum all the way to 30 inches, I would be in space, right? I don't know what altitude space is, but we would be in space. We don't have to go that high. So we're just going to do a small vacuum and we'll cover it later. We'll do maybe 1,000 foot of altitude vacuum. So we'll run our altimeter up 1,000 foot, we'll cap the line, and as long as our altimeter stays there, no leak. Now what's going to happen if we do that is if I lower the pressure on this side of this diaphragm, but I leave the pressure on this side, whatever this is, that means that this side is going to be higher than that side, and my airspeed indicator is going to move, isn't it? It's not going to break the airspeed indicator as long as, now some aircraft are going to say, don't add or take away pressure too fast because they don't like the instruments going wow, wow. So that's a thing you want to check manuals on. The other thing is you don't want to go too crazy high, I say high altitude or low vacuum without having them even. So when you guys do the beach jet, what you'll actually do is you'll cap off the pitot one by connecting it to the box. And then you'll open a valve that says, you know what, any pressure on this side will let mix with the pressure on that side. so that the pressures are the same, and then you'll run a vacuum, and you just gotta make sure you're capped off here. So then you can bring the altimeter up as high as you want. It's just like putting your airplane on your hand and lifting it up into space, right? We're not hurting anything that way. And then you can plug off your vacuum hose, and if the altimeter doesn't move, you go, oh, no leak. But say you do that, we run a vacuum on there, and plug the line off, and then my altimeter starts saying, you're falling. Basically, the pressure is coming back into it, right? Well, we have a leak in our system somewhere. A lot of times you assume it's going to be the hoses, but it's usually the aircraft. So we're going to show you how to deal with that right before we go to lab, when we go to break. My eraser. Making sense so far, and we are going to loop back and do this practically like 3 times with you later in the day. Okay. All right. If my static were to get plugged while I'm flying as a pilot, and I don't have one of these fancy things, what could I do to make sure that my altimeter can still register outside air?
Break the glass.
Break the glass! Yeah, I don't know. I just like this one because I'm a pilot, right? You take your screwdriver and you go, whoop, bam, through the VSI, because these instruments are sealed. So we could make an alternate static source by breaking the glass on our VSI. And now it has an alternate source until I land, and then I probably better get it repaired, right? So anyway, that's a question that sometimes comes up. You probably don't want to break the glass on your altimeter. This is the most important instrument you have. So breaking the glass on the VSI is the way to go. All right. I talked about, because I actually misstated, so we're going to have to undo that a lot of times. What I absolutely do not want to ever put a vacuum on the pitot side, because I don't ever want the pressure here lower than this side. So let's say we get a bug, because we're flying low over the lake. It's Samaritan Aviation. There's our fly. Our fly got stuck in our pitot tube. How am I going to get him out of there? What would you guys? Uh-oh.
Take it off and
Josh is blowing or sucking. Well,
take it off and blow it out.
yeah, take it off and blow it out. So one way is they do make a little like corkscrew wire thing where you can kind of go in and like auger it out. But man, you gotta be careful with that because we don't want to scratch anything in here, like mess it up. So the correct thing to do is we're gonna unbolt it from the aircraft, take it off. Now that we're disconnected, we'll blow it out. But we wouldn't ever want to suck on this to try to suck air through and suck the bug out, because we don't want lower pressure here. It can ruin our airspeed indicator. Okay, so don't ever suck on it. We really don't want to blow on those, and the reason we don't want to blow on them is I can really get that needle jumping. So SMAT aircraft, we don't fly them. Might be a good place to experiment with this. Oh, back up. SMAT maintenance program aircraft, we don't fly them. Might be a good place to experiment with this. I don't want my airspeed indicators broken, so I would rather not have you go, hey, how fast did it move? But a little bit of pressure works. When we get later and we start actually doing these, I'll actually do it once. I'll show you that if you wrap your lips around the end of that bad boy, here's my one, right? And you blow, and then you stick your tongue on the ends. I go until the airspeed's 100, and you get up to 100, and then stick your tongue on the end and plug it off. Now you do have to have your finger over the drain hole, right? So that is that's how AC-43 says to test the thing. It says raise your airspeed to, and we'll get it in the book, 100 is it, 150? Plug it off. If it doesn't drop, you're good to go. Now, so that's what this whip's actually for. Yeah. Ooh, no. I absolutely would not want to use compressed air because it's very low pressure. So that's that's what this is for. I haven't quite figured out the best way to seal this off because it's not perfect. But if you were to put this on your pitot tube, you could blow in here, but back to a lot of aircraft will say don't. So what they actually say is, here, you hold that for me, will you? What they actually say is take a piece of hose like this, and as you wind it up, I'm flattening the hose. I did this earlier with Dean. I got about that far on the 414. That's all it took, and I was at 150 knots. So pretty cool. The other nice part about that is if you have a long enough piece of tubing, or you're on the right aircraft, so I could do that in Grandpa all by myself, because I could have this go through the window, and I can be sitting in the cockpit and I can do this, right? 414, I don't have a long enough hose. I'd have to get a longer hose and deal with it. But that is one way to actually check if it leaks, is you just wind it up, stop at whatever airspeed they say, we'll get to it later. And yeah, it was like that much or less on a system that works. So I'll show you that so you get to see it later, because I saw it in books before, but I never did it until today because I couldn't find the right hoses, and we didn't have airplane that worked, or people that would let you touch them. And I was like, how far do you gotta wind it? It is not very far at all. So we'll do that when we go out to the lab. It's better than blowing, you just gently wind it up. Now, when I go to unwind it, kind of similar thing, right? So if I don't want to blow in or suck because I want to go too fast, when I go to unwind it, I probably don't want to just go, what? Because that needle's gonna back in your gauge, and you don't want that to happen. All right, everybody tracking with me yet? Good. The static ports on jets are usually very well labeled, because they don't want you spraying anti-ice in them. You don't want to take a pressure washer. If you remember from, did you have that class, washing aircraft? You wouldn't want to take a hose. Well, on our small aircraft, usually they're not very well labeled. This one, they put it right in a stripe. Talk about hard to see. So anytime you're washing aircraft, you're doing stuff, be careful. But also, look carefully. Most aircraft are going to have one on both sides. The Beech actually has 4 of them, because you've got pilot side, co-pilot side, as far as instruments, and then you have right side, left side. So there can be quite a few of these on larger aircraft. So you'll get diagrams like this that'll show the system, and I've got a static port here, I got a static port here. It's actually only showing 2. Often larger jets will have drain valves, or I'll just say large aircraft. The idea being, on our small aircraft, they can usually route them. We're not as worried about moisture getting in. It's not as big a thing. On large aircraft, we wouldn't want any moisture to be able to somehow get into the system, and then I can't get it out. So they'll often have drain valves in my system in various points. See up here, sumps and drains. That's a lot of hoses. I mean, if you got on the beach and we go to do this test, and it doesn't pass the test, and they say, okay, go find the leak. Like a rumba, especially because our static system is typically, we're going to call it a negative pressure. We're not going to want to take shop air and add it to the system and then go look for where the bubbles are with soap bubbles, because normally it's a negative pressure compared to atmosphere at sea level, right? So trying to find a leak, it is tough. They'll say use your hand. If it's a big enough leak, you might be able to feel air movement. More often, if you have a buddy and you're using your hand on fittings, you might be able to stop the leak. Like, oh, it stopped. Reality-wise, you're going to disconnect sections. If you go to check Grandpa for us, you're going to disconnect the tube that's going to the back of the instrument panel, or disconnect the tube, but you're going to isolate sections until you figure out where did the leak not happen anymore. So isolating sections is really how you're going to find leaks until you narrow it down to, well, this is the last thing left. It must be leaking. So it's a hassle. Yeah. These systems are often connected to an air data computer on large aircraft, also known as an ADC. A big part of that is it's already too many hoses, right? We don't want so many hoses in the aircraft. So if we run it just to, or minimally to, our air data computer, and then send that signal to all kinds of various instruments, and I don't have to worry about air leaks with all the wires going everywhere. So that's a big part of why we have air data computers, is they're going to be able to send out the pressure to everything else. But also it's part of our system, so know that it's there. We'll have the nose of the beach open. Anybody remember what an LRU is? Yeah, there's a whole batch of them up in the nose while you're working on it. So get a good little gander at all the LRUs when you're in the front of the Jeep. Other name is DADC? Digital Air Data Computer, if it's a D in front of it. So if you go to an air data computer, it's going to look a little bit more like this, where I've got pitot from one side of the aircraft comes into my computer. Pitot from the other side, it might even just skip the computer and go straight to the co-pilots. And basically, we're going to use the word backup there is, you know, if something were to happen to this system or this computer, we still want to be able to see our speed, so co-pilots. Same idea here is, even on the pilot side, we're going to have an airspeed indicator that can get a reading without the computer running. But I only have two little pitot tube lines and one on this side. Static, there are more going to stuff, but where does my air data computer get static from? Right here. Basically one static line coming in instead of running the static to the transponder and running it to my flight management computer and running it to flight blah, 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 blah. So the air data computer, or the digital air data computer, is going to take care of eliminating a ton of our lines for us so we don't have as many leaks. It's okay, it's not that bad. You're flying in Michigan, you're very disoriented. You only get one instrument in your aircraft. Which one do you pick? I heard some altimeters. How many think altimeter? Or how many would say altimeter? Quite a few, yeah. What else?
Airspeed.
Airspeed. Altitude is altimeter. Attitude indicator, says Brian. Yeah. I would tend to, oh, here's a made-up question. I would tend to say altimeter. Did I say, I didn't actually say you're an INC, did I?
You said you're disoriented.
I did say you're disoriented.
Oh, what?
Well, I would say the altimeter is one of the most important instruments, because it's one of the only ones that will tell you if you're going to be dead in 30 seconds or not. Because even if you're disoriented, your attitude indicator might say you're flying level, but doesn't know about the mountains in front of you, stuff like that. If it says 7,000 feet on your altimeter, at least you know you got a minute or two to live. Point being, very, very important. So there's a silly question just to wake you up. We have two different styles, right? We got a baro or barometric, basically meaning we're working off pressure altimeter, and we got a radar altimeter. So this one's gonna be our baro, this one says radar. We talked about this before in common nav class. Our radar altimeter is just shooting a radar beam down to say how high are you above the ground. So he's gonna read height above the ground. The Beach Jet actually has the radar underneath the aircraft for that. It's kind of cool. I never noticed before, but I was crawling under it on my back today for doing other stuff. I was like, oh, look at that. There's the radar thingamabob. It says, do not paint underneath it. So that'll give you a radar. Will this one give you true altitude? Well, let's see, what altitudes do I have? Pressure altitude. Pressure altitude. Absolute altitude. Which one does this give you? True. You truly are going to hit the mountain, is the radar altimeter. That's right. What altitude does this guy give you then? Oh, I just said that wrong. Back up. Absolute altitude is this guy. You are absolutely going to die if you hit that mountain. Yeah, absolutely going to die if you hit the mountain. Absolute is what you are above the ground. Pressure is just what pressure we're in, and then true altitude is going to be what you truly are above sea level. So so I butchered that a little bit. Absolutely gonna die, truly are above sea level. True, absolute. Sorry about that.
Your last one.
Okay, which one is it now?
You're absolutely gonna die.
Right.
That's above the ground, because you die if you hit the ground. True is above, and it's average sea level, so adjusted, so, true. Sorry, absolutely gonna die is, when you hit the ground, how far you are above the ground. We should take a break here shortly. I think, yeah, I have a couple slides. All right, let's take a break, and then we'll come back into this. So, we'll go. We got a couple breaks coming. We'll say 30. 5 minutes. You want a 10-minute break or 5-minute break?
30 will work.
Make it a 10-minute, come back at 35.
Oh, no. Want to join us, Case?
It's actually, I messed that up a little. It's coming up in 3 slides. We'll be back.
Catch up.
Here you go, Josh. This is 3 slides up, so absolute above the ground. I'm more mad that they, yeah.
Radar is ground, and then the other one is water, sea level.
Don't forget your phone. Okay. It's gonna seem like it's 3 times as long.
We should just call it like altitude over the sea.
Yeah,
this. I mean, I don't need it, but
Oh my gosh.
we'll announce it when everybody comes back, just to make it more fun. Give you something to think about.
Woke you up for sure.
Yeah.
Who's your name? Cook them up.
How long was it?
5 minutes. Barely. Ripping by our fingernails at 5 minutes. I can see our teeth. Yesterday wasn't that bad. Yesterday was the easiest day, I'd say.
I'm not doing your timeline, but for me, I think it was by far the easiest yesterday.
Was it harder today?
Yeah. Oh, it was rough.
No.
Tuesdays
Like,
are always the roughest.
It was weird. I started off real strong. Like the first 30 seconds, I was feeling real good, and then it just like,
How hard did you make it?
250.
Good. Good. Very good. That's probably what we started out with, like 2:15, right?
Josh, I told you. You're gonna get some.
Nice to meet you. Straight to the leg.
I don't want that.
I did not say that.
At all.
He was willing to ask me to the day before the class,
Oh,
so
Josh.
that he could be.
Why did you say that?
We couldn't do the words that I did say, although they may have sounded similar. It isn't what I said.
Nothing.
I think you're also just the thing that I said that were incriminating.
Josh, it's okay. You're not
What
alone.
you're saying is
There's
incriminating.
a lot of people here that share the same feelings as you.
You should have joined this case.
I've got something just a little off with me today. Trying to.
You're sick too?
It's right on the edge.
In case you need some garlic, that's gonna help you. Eat a clove of garlic a day until you're feeling better. I swear. I swear by it.
David, don't swear.
Swear by garlic.
Do not swear.
See, I
like
did that for a while, but they would never like show me how to do stuff, so I was always just like the guy who just like,
Oh my.
Oh,
and they were like, they're all too busy.
Yep.
They're like, we gotta get our stuff done like right now. So I'm like, I'm trying to learn what you guys are doing, but you guys are just like,
there are a few days.
You got red.
Yeah. No, I actually had to do stuff, but also something like, I guess we had to get, fitness pack before I eat. What's that called? No, it's just the salad. Anyway, it's from like a 3/4 inch bump. But I'm like, 3/4 inch plywood sheets for a floor. I always
Shuffle them up.
oh yeah, that's yeah. That's you guys are separate for it, dude. I don't run down wood. Down the new.
Oh, hey, there's 10 minutes, maybe 11, as I look at it. Okay, I moved the slide around a little bit, so that's the very next one. So quick review, we have 4 altitudes. We've got absolute, where you absolutely hit the mountain, as indicated by our radar altimeter. We've got, there's actually 5. We've got true altitude, which is saying above average sea level, mean sea level. that's what we adjust our altimeter to read when we're flying. Now, unless we're up in Class A airspace, then we just adjust it to pressure altitude. Pressure altitude is on a standard day. So if you set your altimeter to 299 or 2, standard datum plane, how high would you be? So it's basically just the pressure alone. Density we don't deal with as mechanics. Density is going to be corrected for temperature. And then the last one is indicated altitude, which is obvious. It's just what's showing on your altimeter. It might be true, it might be false, it might be absolute. We don't know for sure. That's just indicated. So a lot of different altitudes. That's a good one to memorize, so you don't end up mixing them up like I did. All right. I don't think they end up with many of these in mechanics class, but let's say I'm flying at the level he is at, and I don't change altitudes. I don't change my height above sea level. I stay where I'm at, but the air gets colder, so I fly into colder air. Is my altimeter gonna say, ooh, you just got higher, or is my altimeter gonna say, ooh, you just got lower?
Lower.
So colder air is more dense, so it's gonna say, ooh, you just got lower. Yeah. I believe that's right. So that's more pilot question, but it affects things a little bit, but not, yeah, we're not gonna go into that detail. All right, inside your altimeter you have, and we're gonna call this a diaphragm or a bellows. Bellows, because there's multiple diaphragms, I guess is how you want to phrase that. So technically we're gonna call them aneroids because they're a vacuum for reference. So we're gonna compare our static pressure that's allowed into our altimeter through the port in the back to our aneroids, and depending on what the pressure difference is between those two, we're gonna get a needle rating up front, and our little adjuster guy for our Colesman window is going to allow us to say, well, it's a high pressure day, or it's a low pressure day, so you gotta get that adjusted to where you're at. So, the hands on an altimeter, there's many, many hands here. So we've got a 100-foot increment, so that one's pointed at the 5, so that's a 500. And then we've got a 1,000-foot increment here, so kind of like the hands on a clock. The smaller one is the bigger number. I don't know why they do it that way. It seems like it should be that way around. Probably because we're more focused on this guy. So right now this guy's at 6,500 feet indicated. They also have this guy down here for a 10,000-foot increment. In our small planes, we don't use him much. But you'll notice he's at pretty much that same 1,000, well, 2,000, 4,000. It's halfway between 0 and 1, so about 6,500. So if I were to fly all the way up to 50,000 feet, this guy is going to end up way over by the 50,000 foot, and then we're back to, it'd be 50,000, 56,500. So you've got 3 sets of hands on most altimeters to tell you how high you are. Here's a chart. It pops up a couple different times. It tells you standard atmosphere conditions. So at 0, at sea level, we're 299 or 2 inches of mercury. We consider 15 degrees Celsius our standard, which is 59 degrees Fahrenheit. Yesterday we were talking, I think it was yesterday, at 10,000 feet, our pressure drops down. There's less pressure around us to right around 20 inches, which if we converted that to pounds per square inch, we would go from 14.7 pounds per square inch to 10 pounds per square inch, I believe it was. And I don't have any of those numbers memorized. Pilots will memorize the standard lapse rate, which I think is 2 degrees Celsius. Is there 2 degrees between each one? Roughly. and that's roughly 3 degrees Fahrenheit, but it gets a little squirrelier as you go up in altitude. This pilot is in a pretty steep bank. Yikes! He's turning to the left. At least his nose is even with the horizon, so he's not climbing or descending. Anybody know why he's banking?
He's got a traffic alert.
Oh, he's got a traffic alert. Good eye there, Kular. I don't know. My guess is that's why he's banking. Let's not run into that guy. Is what that helicopter should have done.
That's
A
great.
little too close to home. A little too close to home.
Hey, that safety system was off, I found out.
Yeah. Turns out,
Yeah.
no traffic alert on the helicopter. What altitude is this guy at? 2,000, what do you think that means? 2,000 what? True, absolute, indicated?
299 or 2, so.
Indicator pressure.
So it's a couple of them, right? It's clearly indicated, it's what our indication is. We're assuming this is our barometric because we're set at 299 or 2, so either it's the perfect day, which it never is, or it's pressure altitude as well. So maybe it's the perfect day, it's true altitude. Otherwise, set at 299 or 2, this is our pressure altitude, but since he's flying, we'll assume he knew what he was doing. So, yeah, vertical speed is, we don't have a number, so he's not climbing or descending, which makes sense with his nose on the horizon like that. Here in Michigan, how high above the ground would he be? Let's say here in Ionia.
1,200.
Yeah, about 1,200 above the ground. We're about 820 off sea level here. So he'd be about 1,200 absolute altitude. If he was out in Samaritan's headquarters in Mesa, he'd only be 600 foot off the ground. Be a little scary dodging planes at that height.
You said it's perfect day, you're referring to the temperature, right?
It's not so much temperature as the pressure setting on the Colesman window. So, we don't know, does it have a temperature?
Yeah, bottom right. Bottom left, maybe?
Oh, 7 Celsius. 7, it's a little colder than the perfect day. Because 15 minus 4 would be 11 degrees Celsius if it was an absolutely perfect day, but we're getting off into the weeds. Okay. Yeah, so going back to our Colesman window over here, if I call up Ionia AWAS, or I look it up on ForeFlight, I can actually call them, it's a phone number, and it'll read off what the weather here is in Ionia. I think they have you do that for your lab. It used to have that. I'm not sure if it's this one.
We've done that lab in general.
Different class. So it'll tell you, now that is not the pressure here at Ionia, remember. It's not saying that's where we're at. It's saying if you drilled a hole 800 foot down into the ground and jumped into the bottom of that hole at sea level, that's what the pressure would be there. So just make sure you're familiar with that. All right, I'm going to draw some names because we've got some slides going. This person's going to tell me what altitude are we at on the altimeter on the right, Trevor. Say that again. 9,100? 910? Final answer? Yeah, good. Okay. So our 10,001, it's nowhere. We're ignoring that. I don't ever look at that anyway. Teaching this class, I was like, what was that thing again? I never fly that high. 1,000 foot. So we're pretty much at 1,000, right? At about 1,000. And we go, okay, so I'm just under 1,000 foot. So I'm at 900 feet. And that's probably 20, 40, 60, 80, 100. So that's indicating 920 foot, basically above sea level is basically what's going on. Okay, Leo was my next one. On the left, how high are we?
895.
Yeah, about 895. Okay. roughly 1,000, so down to the hundreds, 800, and I'm double checking, it's probably not 10, 20, 30, 40, 50, so 20, 40, 60, 80, 100, so 820. So, this is actually taken of a SMAT aircraft sitting here in Ionia with the Colesman window set to the correct setting for the day. So I went over there, I don't think I called Ionia, I just said, I'm getting ready to go fly. So I'm gonna spin it to 820, and that's what AWAS would have been reading me on that day. If I set it to 299 or 2, it would have said I was up here, different numbers. So if I said, what is my true altitude this day, what number would you give me, Steven? Yeah, what number is that again? Oh, right one, I'm sorry. True altitude is above sea level, so it's the right one. I'm facing you. Sorry about that. Right one. So true altitude is above average sea level because I'm set up correctly. So if I'm standing here on the ground in Ionia, I'm truly 820 foot above sea level. So this one in Ionia set correctly. What is this telling me? Next person. That one's telling me my, looks like Austin. I am not 800 foot off the ground because I'm sitting in the hangar, so it's not absolute. We'll take another name. Brian. Pressure altitude. We're set to 299 or 2, so it gives us our pressure altitude. Alright, that is correct. So, setting it to 299 or 2, we'll read the pressure altitude. Okay, here is a screenshot from that day off my phone. If you know how to read a TAF, ooh, it's hard in green, isn't it? Zulu, the winds, overcast. Here it is. Altimeter setting should be 2979er. 2979er. Hey, we're pretty close. If you're not good at reading TAFs, because you got to know pilot speak, you can scroll down on ForeFlight a little further and find your altimeter setting here. 2979er. So, a couple different places, a couple ways it might be listed to say, what am I supposed to set in my Colesman window? This is a fun one. Setting the altimeter to 0. Everything is zeroed. That's going to tell me my actual pressure. So if I set it to 0 and read my Colesman window, it'll tell me what the air pressure is where I'm at right now. So if I read this correct, I'm below 2890, I'm above 2880, so 288246. 8, I would say. 2888 is my actual pressure that I'm at right now. So if you set it to 0, it'll give you your actual air pressure that you're in. Kind of cool, right? Now if I go up to a really high mountain, like say I'm in Denver, I might not be able to do this because the Colesman window might not have enough range. I might not be able to actually get it all the way down to 0 because, you know, the Colesman window's got to start and stop on each end. So you might not be able to do that if you're farther from sea level. But if you're anywhere near sea level, setting it to 0 will give you the actual pressure around you. This doesn't show up in many prepware questions or FAA questions, but I explain this one to you so that you know when you call the AWAS or get the reading, they are not giving you what the actual pressure is. They're giving you what you would have to set in the Colesman window for your altitude to indicate true altitude. Everybody tracking with me on that? Alright, so that's a fun little trick you can do sometime. Set it to 0 and see what pressure you're at. Alright, we're skipping that one because we just took that one. Alright, if your altimeter is not reading correctly, it could be one of, well, I have 3 errors, but why did I put 3? Temperature errors. The bellows are metal, they're made out of metal, so if your altimeter is freezing cold, it might be a little bit off because they probably calibrated it stuff, like that's the altitude. The temperature error is, your altimeter is designed to be in your airplane at the temperature you like to fly in. So if all those metal bellows are the wrong temperature, it might give a bad reading. So they like to give you that temperature error. Pressure errors refer to where the static port is picking up on the aircraft. So if I'm slipping or that port gets plugged, something like that, that would be an error on the pressure error side. It's basically we're feeding the altimeter the wrong pressure, so it's giving us the wrong altitude. That one makes sense, right? Scale errors, it's the name they give to errors in the mechanics of the altimeter. So it's not so much like you set it to the wrong scale as much as they had to give a name. I would have called that one mechanical errors, but for whatever reason, the FAA in your book will call that scale errors. Scale errors is something with all the linkages in the altimeter is wrong. The closest I can get for trying to remember that is we're reading a pressure difference, right? And we have a scale that's reading the pressure. It's a pressure reading scale called an altimeter. So that's the closest I can get to trying to help you remember that one. But scale errors is something mechanically awry. Static system leaks, we're going to deal with in lab and whatnot. Obviously, if my static system is leaking, we talked about how the inside of the aircraft is often a different pressure than outside the aircraft, even on our little aircraft. Obviously, in a pressurized aircraft, that could be even bigger, right? Because the altimeter is in the pressurized section. So that would be static leak errors. And then hysteresis errors is just a fun word to say. One of the reasons we have to swing our compasses, if you remember, was that the airplane sits in the same place for a year. Well, same kind of idea, hysteresis error with our altimeter is if you haven't been flying in a long time, the thing will get to where it likes being there, and then I go fly, it might not like being in the new position with the bellows, so an error because it doesn't like being, we call that hysteresis error. That's one of the reasons you as an A&P are not going to be able to certify altimeters, is they have a lot tighter tolerances in how they're going to check your altimeter. They're going to bring it up, bring it down, bring it up, bring it down, leave it up, long time, bring it back down, long time, bring it up. They're going to move it all over and then they're going to check it, and it's just more than they want A&P mechanics to do. So hysteresis error is just the history of where it's been for a while. All those make sense when I explain it. Any questions on them? Okay. Vertical speed indicator is VSI. It gives us our rate of descent, and we talked about the key in there is our restricted flow in or out of the it's actually the port. So here's the restricted passage. Alright, quick review. What is this actually measuring? On the very basic level, David. Pressure difference between
outside air pressure, or like the ram air pressure, and static pressure.
yeah, ram air or pitot we call that. Ram air and static, which is just outside air. That is correct. How fast does this show we're going, Tim Peterson? It's a little tricky. Oh man, all of a sudden we got a lot of numbers going on, don't we? Let me see if the next, well, we gotta stay with this one. I've got a 120, 125, 130, 124, 124 what then? Alright, actually, mile per hour, yeah. You gotta watch watch these close, because depending on the aircraft you're in, they'll usually give you both. So this one has mile per hour out here. It has knots on the inside. And if you're to look close, 100 is here, 120 knots is here. So on the knots scale,
120 knots is further out.
104 knots.
what's the one, what's this number?
140.
120, look at the inside.
I don't, oh, okay, yeah, sorry. You're right, 120's here for knots. So we're only doing 105 knots, is what it's saying.
Is that a 140 though?
And this is a 140, so what's happening, if you look at this one close, we'll switch to one that's cleaner, is we can adjust these, this little section of the window, we can adjust based on the outdoor air temperature. Because remember, our temperature of our air, less dense, more dense, we're dealing with this ram air. So if we really want to be picky about how fast we're going, what we actually come up here and do is we say, what temperature is it outside? It'll be easier to show on a different one, but we'll line up our outside temperature. This doesn't say Celsius or Fahrenheit, I'm assuming Celsius. And then we'll line it up with our pressure altitude. How do we find our pressure altitude again? Not 0, close though. 2, 9, or 9 or 2. So usually you want to write down what it's supposed to be because you'll forget. You have to listen to the radio all over again. So write down where you're at. You go to 2, 9, or 9 or 2. Oh, my pressure altitude today is, say, 5,000 feet. And I line my 5,000 then up with whatever temperature, that corrects this scale. So basically, all the way back, we got mile per hour, and once we get into this critical of cruise flight, we can fine tune that based on temperature. So I'm showing 124 mile per hour, assuming it's set correctly. The knots is not fine tunable. I'd have to do some math from there in this particular airspeed indicator. So here's one that's a little easier to read. Let's say this pilot has it set correctly, and he is flying at, I'll try to pick an easy number, he is flying at 10,000 feet. What temperature is it outside Isaac Finney?
So if he's flying 10,000 feet,
Yep. So yeah, so there's 10,000, so 0, 10, 20, 30, so actually negative 15 Celsius if he has it set correct. I realize you guys are, well, I say far away, but the thing's this big. So when you're flying an airplane, this does get tricky. But if he's set correctly at 10,000 feet, negative 15 Celsius, we go, okay, if that's set correctly, then this will be accurate. How fast is he flying in mile per hour, Micah? Assuming it's set correctly.
So are we looking at the white thing?
We are, as long as we're assuming it's set correctly, yep.
203 miles per hour.
I'll take that answer. We got 200 here, 210 up here, that'd make that 2. So 203 miles per hour. Okay, I don't want the quick knee jerk. And if you need a pass, you can, John Stoll. But how many knots is he flying? And you may phone a friend if you want. And I want to know accurate knots. I gotta double check myself.
phoning your friend.
All right, you have an answer?
Roughly 170, I think.
Are you basing that off this one? Because this one's saying 140,
Well,
150, 154.
Well, if you follow the outside ring of numbers up to the 200 in the yellow part,
Oh, I like how you're doing that.
if you go 201,
So you took 203
175-ish,
and came in here.
roughly, yeah.
Yeah, 176.52 actually. Because a knot is 15%, a nautical mile is 15% more than a mile per hour. So, 175. So even though this one, it's like, whoa, why does it say he's only going this? It's because this inside ring is not corrected for his temperature. Is why that inside ring we're kind of throwing out if we're set correctly. So John took it a step further than me. I took 203 and I did 203 divided by? No, times. Divided by 1.15. I had to do it both ways to make sure I had the right number. And that gave me the 176. He was one ahead of me. He's like, hey, I got a scale. We might even call this a whiz wheel of sorts. He just went up to 203 and then transferred it over to where that is on his automatic conversion scale. Yep, we'll explain it one more time. So this white section here, as I turn this dial, is going to move. All these numbers are going to move. Because they're going to get adjusted for my outside temperature. So we're assuming, because I told you we're assuming, we're at 10,000 feet. So the pilot's going to turn this guy, and we said, hey, it's negative 15, I think is where we said that was at. Right there, negative 15 Celsius. So he looked at the temperature gauge in the cockpit that said negative 15 Celsius and said, okay, I'm going to line up negative 15 Celsius with 10,000 feet. Now I have the correct numbers in here. So I know my mile per hour is correct. So my mile per hour is 203. Okay, you with me so far? All right, so I can just do the math for knots now. 1 mile per hour equals, I should have done this the other way around. It's 1 divided by 1.15 knots. The other way would be to say 1 knot, KTS, equals 1.15 mile per hour. That's the one I would remember if I was you. It's a 15% difference. So I could take my 203 and put it in whichever formula I want, and it'll spit out my knots. So basically if I take 203 and divide it by 1.15, that's going to be 176 mile per hour. Good with me there? And then what he did is he said, well, this scale compared to this scale gives me the 15%. So he just took his scale and he was like, okay, I'm going to go up to my 203, because actually this 203 is essentially 203 on the outside. And he said, I'm just going to transfer my scale over 203 here. Brought me for knots here. There's 170, 175, 176. So yeah, a lot going on there. All right, I think we might have one more slide before we do a little art contest. Maybe not contest. Is it a contest if only one person's in it? I need somebody to draw an airplane on the board for me shortly. I was going to draw my own, but you know, we'll see what you guys do, and because we're going to need it for later. There's the conversion chart for if you wanted to have some fun. It's 15% difference, and it gives you the same thing reading across. But just for the fun of it, if you wanted to play around with that at some point. As much as I like old school and steam gauges, you typically don't have to do any of that in this guy, because once you go to a digital format, he is going to be smart enough to tell you it's negative 27 degrees, ooh, he's high, negative 27 degrees Fahrenheit outside, and I know what I'm set at, so he'll do all the conversion for you. You don't have to mess with our temperature in the new ones. So that is the handy part with that. Just the FYI. 25,000 foot above sea level, he's not a float plane. Alright, I'm supposed to tell you this, Mr. Mechanic. get in an airplane, don't break the speed barrier, the sound barrier, because it could be hard on the flight controls and it could be hard on the instruments. And it might be, so it's a prep work question. I'm like, if you can get in an airplane, figure out how to get the gear up and break the speed barrier, I shouldn't have to tell you this. But it is a prep work question. They don't want you near the speed of sound Mach because our pressures and stuff, they do wonky stuff. And anyway, I was like, really? You guys are gonna put that in prepware? But I guess they are. So a Mach meter will tell you how fast you're going relative to the speed of sound. Now, I'm not gonna get way off in the weeds, even though it's fun to talk about. Depending on how high you are, the density of the air, the speed of sound changes. So the speed of sound is not a constant. It changes. So your Mach meter typically is going to be accurate in the air density that you're flying in, that it's reading. So just a FYI, if you're looking at your Mach number, you usually don't have to make any adjustments for air density because it's already like pulling all that, let's say, info into it to say, where am I at? But don't fly faster than the speed of sound, okay? Everybody got that? All right, we are gonna take a break, get an airplane on the board. Maybe we can just use that one. And then we're gonna come back in and do some mock pedostatic tests, and then then we'll go out and do some real pedostatic tests. So short break, 6 minutes, come back a quarter after. Any volunteers for drawing an airplane for me? Parker, thank you. Any airplane you want. I just need a pitot tube and a static board. That was really weird and gross for just a second. Thought I had water, turns out it's iced coffee. Oh man, my brain was like, whoa.
When you're actually flying with all those conversions and stuff, do you look at a chart, do you just do that?
It's on all of them.
Okay.
So like, give me one, and I'll answer your question. Like knots to mile per hour, I typically only gonna care about one. The POH is gonna say knots.
93 miles per hour.
What? Yeah, right, so my POH is typically gonna be either all mile per hour or all knots, and I'm gonna ignore the other one. So it's, that one you're really not gonna use. It's more an education question. Like when we sit in here, part of why I spend a little bit more time on it is to point out, so when they ask questions, like say a prep work question, if they say, how fast are you going?
Yeah.
Well, wait, knots or miles per hour?
Yeah, just kind of train you to feel and go along.
Yep, exactly. Pressure altitude versus density altitude, we will do as pilots. Typically, that's before you go flying actually. If you're doing the performance for how long is it gonna take, how many foot of runway to take off. We'll have to get our density altitude, so we might check the pressures and temperatures and do that all on the ground at a time.
Would there be any occasion that you like switch it around to get like in flight, like
Yep.
okay now you want to see your pressure, now you want to see your
Yeah, so if I need to correct my airspeed indicator, not even correct, but just set it correctly, that's one where you would wanna check your pressure altitude. And that's where I was saying, let's say ATIS says we're set at 2973, and I've got it set in my little Colesman window, and I go, okay, I wanna set my airspeed correct. So I need to change this to 2992 before I actually spin it over to 2992. I'm gonna write this number down on my knee or something, so that now I set it to 2992. I read what my pressure altitude is, and I'll write that down on my knee. Maybe I'm at 4,000 foot pressure altitude, and then I go look at my number and go, where was I set again? Oh yeah, because otherwise you
Did you
forget.
just switch it around for different numbers you're trying to find, right?
Yeah, so you're always gonna fly with what you're supposed to be set at, but
So that's the plane think here.
only reason I switch it would be to obtain another number, and then I'm gonna switch it right back.
Okay.
See why I didn't draw it? You can't decide, can you?
How much break left do you have?
You got about 3 minutes.
Okay.
Okay.
No what? We're going simple.
I was gonna say, do I need to bring that guy back up?
Ooh, trace it. Trace the marker and then turn the screen off.
Hey,
802.
should we? For the people that aren't here.
Pretend that you're really.
Like, wow, he's really good.
I mean, he is, but you're not giving him enough time.
See what he can do.
Depends if you're playing Pictionary or you're trying to sell fine art.
He could tell you something.
Say what?
He could tell you something.
I bought airplane art before. You go in our office, Dean's little, next to Oshkosh, it's got the little postcard of the four-point base. Bought like 30 of those from the artist that drew. Alright, this will be fun. We'll see if he's still a student or if he's well on his way to being an MP.
Uh-oh.
Go ahead and give me my,
I'm getting there.
pitot tube pitot tube and static board.
So your static point is gonna be on the curve. That other static board was yours. Was that one?
It's close, yeah. Real close. Alright. Looks good. Nice.
Ooh.
Well, it's time. Alright.
You got it 15?
15? Is it 15?
14 still.
Yeah. I got 15. Bring
He's
it
got
up.
5 seconds.
Is my clock off? I'll do it 14. 14. I have to adjust my watch. There it goes. Oh, you're right. They say that thing's atomic. I don't know what that means. I think you're right. I also, I don't know if it's hooked to satellite or how, no?
Nah, I don't really know how they work. It's some, they're like measuring electrons on an atom or something. I don't know. Something like that.
It's not supposed to keep time.
Okay. It'll still be wrong. Alright, here we go. Finally, the fun part. I mean, the fun for you. Alright, how to test a pitot system. In AC-43, okay, back up a little bit. Maintenance manual, right? Always go to the aircraft maintenance manual. And if there is not instructions in the maintenance manual, you can go to AC-43. So, in AC-43, 1257 is the paragraph that you're at, roughly 1257 here. And if you go to 1260, it has maintenance precautions. So I didn't want to just plain read these and bore you. chance on your own time, because they're important. They're basically, the short version is make sure you know what's up with the aircraft, make sure you know how fast you can raise and lower the pressures, because they don't want you to raise and lower pressures outside the range of what's in the aircraft. So basically what they're saying is, hey, if the aircraft doesn't tell you how to do it, you better go to the actual instrument and make sure you stay within the instrument's limitations. And then there's a couple more things beyond that, but that's the basic gist of it. But 1257 will say testing the pitot system and testing the static system. The pitot system test, it'll explain it with this. I already did that. We'll walk out to the 414 and we'll do that in a minute later. The other way is if you have a fancy box like this. This is the box, or very, very similar to it, that a instrument repair station would use. So we have one here to do some of the tests that we're doing. This is way overkill for what AC-43 or most of your books would say. So don't think, hey, I need one of those fancy boxes. You could use a piece of surgical tubing, you could use your tongue and blow on the thing. On the static side, very similar. What we're gonna do is on the static side, we're just gonna plug off if there's a separate static port on the other side of the aircraft. On the one we're using, we're gonna bring the altimeter up to 1,000 feet. And then we're gonna start a stopwatch, and we wanna go a minute, and as long as it doesn't drop 100 foot in that minute, we're reasonably leak-free. On a perfectly leak-free, it doesn't move at all, but they'll allow you, AC-43, to say, go up to 1,000 feet if it doesn't drop more than 100 feet in a minute. When you guys do the beach, I believe the number, I'm gonna throw out the wrong number, just so I don't cheat with you. The beach will say bring it up to 21,000 feet. That's the wrong number. You gotta look up what the right number is for your lab. But it's gonna be really high. It's not just 1,000, but it's really high. And then they're gonna say, I think it's 3.5 minutes, and they give you a certain drop. And what sticks in my head is 700-800, somewhere in there. They'll allow that much drop in 3.5 minutes. But if we wanted to do the very, very basic test, you could just grab from your toolbox. Where is it? I had a different one. Oh, it's out by the airplane. We'll just do this one. You could grab a little tube. You could put a little sticky stuff around the outside. You could go walk up to your static port and go, I think it's hot, and then the air can't come in and out, right? And if you stay there for a minute while your buddy's inside the aircraft, as long as it doesn't drop below 1,000, you're good. So that's all you technically need, and if you don't even want that, you could actually just put your lips right on the side of that thing. Now, that said, there's moisture in your spit and stuff. Anyway, so you don't need all the fancy stuff, but it makes you look like more of a professional. Now, if you're on an aircraft that requires it, obviously, you do. Pitot tube we talked about, I just threw that picture in there. And my slides got funny, I can't read my computer screen. This is off the 206, and it talks about how to do it, and basically it's going to talk about, I can't read on here, it's going to talk about using this type of system for the pitot and the other on the stack. So let's run a fake one a minute on this fine aircraft Parker drew us. Now one test, and probably the first one I'm going to do, is my pitot system test. I'm going to hook my pitot checker up to the pitot tube. I'm going to, okay, we'll roll it up. So say he's stuck on there, we're going to roll this up. We're going to watch the airspeed indicator. Did it say, let me double check my book, how fast 1 minute, the leakage should not exceed 10 knots is what it's saying. So basically, this goes on here, I roll this up to 150, and we wait. If it doesn't get below 140, I go, oh, good, the pitot system's good. Now I want to test the static system. I'm going to plug it into the static. I'm going to draw a vacuum up to 1,000, plug it off, and wait. I believe that one was the 1 minute, and it shouldn't go less than 100. So that's how we can do it, the cheap wad version. But if you have the good tools, and here's what you're going to do, we're going to get fancier and fancier as we go. This is one way to plug into your static port on your aircraft. Notice there's still a hole on the side, right? So he's stuck good. I would highly recommend, before you use these tools, to make sure that the hoses aren't leaking themselves before you do all this. I did that already today on a set, but you might be changing hose ends. So the way to do that is you can just put a piece of the putty or whatnot on the end of your hose. Well, I might need a helper up here because it doesn't want to stick. The other tube, we would hook up to the pitot tube. Notice I labeled A and B. A and B. If you hook them up backwards, we'd be putting the pressure on the wrong one, right? But this says pitot, this says static, so I have them hooked up correctly. I'm going to just put a piece of putty on here for now because I don't really have a pitot tube. So the way this box works, is we've got a pump that I can either make pressure or a vacuum, and when you get up close you'll be able to see it better. I've got it set to vacuum right now, but by pulling the handle I can either make vacuum or pressure. Vacuum shows up here. If I switch it to pressure, it'll actually pressurize a can in the other side of this thing. These are valves, just like a normal valve. If I spin it open, it's open. Closed is closed. There's a note, really important. You might think, if I really crank it down, I won't have a leak. You will wreck them. They're very highly tuned adjustable valves that you can have partial open, partial close. So just barely kissed close is fine. It will seal off. Please don't crank those down. They're really tight. So we've got a pressure and a vacuum. It's just a tank in the back of here. So if I'm on the vacuum side, let's say, well, we'll go to the pressure side. We'll say we're doing our pitot first. As long as this valve is closed, and I just have this capped, I could hook up shop air to that or nitrogen. Same thing here, I can hook a vacuum pump, but I'm gonna pump it up. If you were by me, you would see my little pressure dials going up. I'm filling up the little canister in here. And then basically what I would do, where'd the end of my hose go? Lost my piece. Basically what I would do is I would open, I'm gonna make sure that's closed, cross feed is closed. I would open up until I get to 150 knots, right there, close it, and I'm gonna wait, is it a minute? Use a minute, double check AC43. As long as it doesn't move, I don't have a leak in my system, right? Easy enough. If I have a leak in my system, I'll be careful how I do this, it would move. So, if I were to do that again, bring it up, normally you don't want to just pull it off. There's a vent, so when you disconnect things, you can just open this up and you can slowly vent the pressure. There it goes. Very fine-tuned valves, so, and you can vent that down. So, we'll say this is hooked up to an airplane. We just checked our pitot system. It doesn't leak. Everybody good with that? Cool. Now our static system, we don't necessarily have to have this connected to our pitot tube if we're only going to 1,000 feet, but if we're going to go up really, really high, remember from our picture, our airspeed indicator in the aircraft, 1/2 is the static, 1/2 is the pitot. So what we actually do is we will open up this cross-feed valve. That basically bypasses our airspeed indicator diaphragm, so that both our pitot that I'm connected to, that we know is leak-free now because we already did the test, so our pitot and our static will be the same pressure. I'm not flying through the air, and that works. If I didn't do that, and I'm going to switch over to the vacuum, put myself some vacuum. If I didn't do that, and I raise my altitude. Let's see, it'd be this one. Did I not pump it? Oh, there we go. I don't think I pumped it far enough. Can I have a volunteer to hold this? Tell you what, that was fun, but I'll just put a piece on. There. Let's try that again. Give myself some vacuum to work with. Alright, so I'm at 900-ish. I'm going to raise it up till I'm 1,000 above 900. Notice this side's moving. It's because I don't have the cross feed open, right? So I lowered the pressure on my pitot system, but my static system is just reading atmospheric yet. So if I have both of them plugged, oh, that's tough stuff. If I have both of them plugged, ooh, sheesh. There. Like you will on the aircraft, and we'll do this in a minute. If we have both of them plugged, get myself back up because I just lost my 1,000 foot. There we go. It moved, or I can have my cross feed open. The cross feed just neutralizes out across this. So I gotta go a little bit more because now I'm actually testing both systems. There's my 1,000 foot, and I wait for a minute. As long as it doesn't move in a minute, we're good to go. Okay, so that's this device, and what I'm going to do is we're going to roll it out there. We're going to do this on the 414 because the 414 tests good, and then we'll have group one start with Anna on the beach jet. So cross feed is just bypassing that. So then I would want to vent, well, let me think through that. I never want lower pressure on here, so we'll vent this one first. Bring that back down. The cross feed's still open, so it's bringing them both down. This box, and I will admit, I might not have taught it the best, but if you only ever use it once, you're gonna be like, but you do it 2 or 3 times, and it starts to sink in. So even for me today, yesterday I was like, oh crap, that box. By the end of the day, you're like, oh, I totally get this thing. So, all right, questions on the general idea of what we're doing, and we're gonna go out in the lab and do it together a bit. Okay, let's head out to the 414.